Welcome back for part two of our second day of permutations and combinations. We're specifically focusing on situations, usually on this page, we're on page 6 of the probability packet. And for a lot of these situations, order is not going to matter. And we learned that that's called a combination. So I'd like you to pause the video. And if you haven't already, can you try your hand at all these questions on page 6 from 14 down through number 20, just so you can make your decisions and opinions before we talk about it on the video. There's some good ones on this page. Now let's go over some of them. So 14 says a lottery that requires guessing 6 numbers out of 50. And here is your ticket to use a combination. It says in any order. Sells $1 tickets, doesn't really matter what they're selling them for, and somebody's going to go buy out 12 million of those to make sure they're going to win. Let's find out how many combinations there actually are so that we can see if they really would be guaranteed to win. So order doesn't matter, so we're picking out of 50 numbers, 6 of those, a 50C6. We'll get that into the calculator. Let's see if that number is greater than or less than your 12 million, I think that was. So 50... math probability number 3, and you're picking 6. And I don't know if there are many lotteries where order doesn't matter like this, but this one has 15 million combinations. 15 million, almost 16 million, 890,700, which is greater than 12 million. So the answer to that person's question is nope. They are not guaranteed to win because they haven't bought out all the possible combinations. A standard deck has 52 different cards. Get used to talking about playing cards. That is a common application of probability to talk about a standard deck. For now, if you just know basic info about a deck of cards, you'll easily be able to answer 15 and 16. So for instance, there are 52 cards in a deck. That's important. It's also important to know there's 4 suits, right? Spades, clubs, diamonds, hearts. So we'll use that information in number 16. First, it just says how many 5-card poker hands are possible. So in poker, you just get, in one version of poker, you just get dealt 5 cards, any 5 cards. The order doesn't really matter. In most games I play, if the dealer's dealing out the cards, it doesn't really matter that he gave me the ace first or second or third. It's still a part of my hand. So I'm going to say in this case, we've got 52 cards. And we want to choose or find out the combinations of 5 card hands, a 52C5. So go ahead, use the formula or type it in to get 2,598,960. Okay, so a lot of possibilities, right, for those card sharks out there. Then the info about the suits comes in handy for number 16. How many of those 5-card hands contain only spades? Don't let the 5-card hands kind of bog you down. You don't really need this number to answer 16. You just need the amount of ways that you are going to pick 5 spades for this situation to work. So how many ways can you pick 5 of those 13 spades? Spades are a quarter of the deck. There's 13 of each suit. So you have 13 spades to choose from, and you're picking 5. All spades get chosen, right, for this possibility to work. So this one I thought was a little trickier. The 52 wasn't really useful here. How many ways can you pick 5 spades from 13? And you get 495. Okay. So they play around with the numbers here. Sometimes some of those throw you off a little bit. How about 17? Each year, a company holds a drawing in which 3 of its 100 employees get free vacations to Tahiti. I'm going to circle this one too as a little bit tougher. What is the probability? That's what we get more into later in the packet, that the 3 employees are the 3 bosses. Okay, so let's think about it. Let's think about the number of ways this company could really just pick 3 people to get free vacations. I don't think the order matters. They're all going to Tahiti, right? So we can use a combination. You have 100 employees, including the bosses, and you're going to pick 3 lucky winners. So let's see how many total combinations there are. Type that in, get 161,700 ways. What are the odds that those 3 specific people that you pick are the 3 bosses? Well, that's one option, one way, out of this amount of total ways, out of 161,700. You have a 1 in 161,000 chance that that one combination will be chosen. So if the 3 bosses get chosen, there's probably something up. They probably rigged the competition. A class of 250 students wants to elect a committee of 4. All they have to do is, that's not a really fun committee. They just have to buy supplies for a homecoming float. I guess maybe that could be fun. But the big thing is they don't have specific roles. You can use a combination for this one. So 250 students possible. How many combinations of 4 students would be within the 250? So that's a 250C4 is 158. A lot of ways. 1,882,750. Yikes. Lots of possibilities. And how many ways can you select 4 books out of 12 to take with you on a cruise? I'm not getting into semantics here. I'm not talking about the order in which you're going to read the books. It's just you're grabbing 4 to put into your backpack. I don't think the order should matter here. You have 12 books to choose from. You're picking 4. 12C4. We already got this answer actually, but another 495. Oh, I want to show you something cool. I could put a circle around my answer. I should be doing that to make it a little bit neater. Okay, we have one more. A pizza place, now I'm getting hungry for lunch, offers 10 toppings and 3 sizes of pizza. How many different pizzas are possible that have 4 toppings? Well, let's think about it. This is a 2-parter because we have to bring in combinations of sizes and combinations of toppings into play as well. Let's do sizes first. So we'll say sizes. There are 3 sizes and you're picking 1. So out of 3 possible sizes, you're picking 1. And then let's talk about toppings. We want a lot of toppings on this pizza. This place has 10 choices for toppings. Order, I don't think it really matters. I guess you could argue that it matters whether like your peppers go on top or your pepperonis go on top, but let's just not get into that. Let's just say it's all going to the same place. So you're eating, all the toppings are on there. I'm going to make it a 10C4 because we're choosing 4 toppings, and these are for the toppings. Now, it's kind of silly that I wrote that 3C1. I wonder if anybody's been wondering about the 3C1. What is 3C1? How many ways are there to just pick 3 things or pick 1 thing out of 3 choices? There's 3 ways. You could pick the first size, the second size, or the third size. So really just this is the number 3 times 10C4. 10C4 I'd have to do a quick calculation for to get 210. We will multiply the 2 and get 630 as your final answer. I hope you guys have a great day. And a little tidbit, what's a way you use the word combination all the time? Locker combination, right? But doesn't the order matter when you type in your locker combination? I feel like it does because the wrong order won't open your locker. Some of you don't even know how to open your lockers, and that's another problem. But from here on out, don't call it a locker combination. You should be calling it a locker permutation because the order actually matters when you type it in. All right, you guys, have a wonderful day.